All right, hello everybody. Welcome to the second lesson of quadratics part 2. We're going to be going back to look at factoring today. And before, we were just working with certain types of trinomials in the last unit. And so we're going to expand our factoring knowledge and skills. So let's just go into presentation mode. And sorry about the background noise. There's now an air conditioner in this room, thankfully. So you might be hearing it come in and out. Okay, so our learning goal today is to be able to factor trinomials of the form ax squared plus bx plus c, where a is any number. Last unit, we did factoring of this form when a was 1. So now I'm going to go over a couple different ways you can do this um, when a is any number. Okay, so just to review, this is kind of what we worked on last unit. Remember when we did the X's and oh yeah type puzzles to help us factor? And this is kind of what we were doing. So this is a finding common factors. So find two numbers that multiply to get the number in the first column, so the product, and add to get the number in the second column. So what we want to do is find two numbers that multiply to give 21 and add to give 10. So you may want to pause the video here and see if you can find the pairs of numbers that can give these products and give these sums, and then I'll go through them. So the first one, product of 21 sum is 10. Well, that's 3 and 7. 3 times 7 is 21, and 3 plus 7 is 10. And we can just kind of go through that for these numbers. What I like to do is I like to list the factors of 21. So you might say 1 times 21, 2 doesn't go into it, 3 does, 3 times 7. And then I figure out, oh, 3 times 7 is 21, and they also add to 10. And we can do the same thing. And I'm going to show that throughout this presentation. So I'm not going to do it here because these are kind of like puzzles right now, kind of with no end goal, but it's a way to get used to finding common factors. So two numbers that multiply to give to get 12 and add to 8. Well, that's 2 and 6. Two numbers that multiply to 32 and add to 18. 16 and 2. How about with negative numbers? So two numbers that multiply to give negative 20 and add to give 1. So a hint here is if the product is a negative number and the sum is a positive number, actually, it doesn't matter if the sum is positive or negative. If the product is negative, that means you have to have one negative number and one positive number. Because the only way to get a negative number when you multiply two numbers is if you have one of each side. So what works here is 5 and negative 4. Because if I do 5 times negative 4, I get negative 25. Sorry, negative 20. But if I add them, 5 plus negative 4, it's positive 1. What about this one here? Something multiplies to negative 64 and adds to 0. If it adds to 0, the numbers have to be the same, don't they? But different signs. So what's a number that can multiply by itself to get to 64? Well, 8. 8 times negative 8 is negative 64, and 8 plus negative 8 is 0. So that's just something you can practice because that helps us be able to factor these trinomials, sorry. Okay, so factoring is the opposite of expanding. We talked about that last unit. And what we need, the first step when we are factoring trinomials is you really need to find two numbers that multiply to give a times c, and I'll show you some examples, and they also add to give b. Now, last time when we did this, we did the x's and oh yes to help us set this up. This time, I'm going to show you two new ways to do it that you are going to see in years to come. So I really want you to be familiar with these, and then you can just choose the one that you feel most comfortable with. Okay, so one way, and I think we did this before, so I'm not going to spend too much time, is factoring with algebra tiles. This isn't exactly the best way to factor because it's not like you're carrying around algebra tiles with you in your pocket, right? Um, by the way, you can get factoring calculators online, so that is a way that you can check your work. But hopefully, you will learn how to do it the long way around, if you will. So, it does give a nice visual how this works and why it works. So let's say we want to factor with algebra tiles and we have x squared plus 8x plus 12. Well, remember the first step is to take out all the tiles we need. So we need one x squared tile, 8x tiles, those are the rectangles, and then we need 12 of the single tiles. And then what we do is we need to figure out how to make a next nice rectangle out of this. And if it doesn't become a nice rectangle, that means it can't be factored. So to make a rectangle out of this, you always put your x squared tile in the top left. You always put your single tiles in the bottom right, and then you line up your X tiles to make it into a rectangle. And sometimes you kind of have to play around with the layout to make it into a rectangle. And then to get your answer, you just count how many tiles you have. Well, this rectangle has, or sorry, the square has a side length of X and 1, 2, 3, 4, 5, 6. So X plus 6 is the first side of the rectangle, and the second side of the rectangle is X plus 2. Because you can imagine if I find the area of this rectangle, it's X plus 6 times X plus 2. Cool, eh? I really like that. And what I'm going to do now is we're going to use the area model to help us factor. We're just not going to do it with tiles because like I said, we don't have tiles in our pockets when we're doing this kind of stuff. So, let's factor using the area model then. So let's say we have this equation. We have x squared plus 5x plus 6. And your first step is to figure out what's A, what's B, and what's C. So our A, there's no number here, which means it's 1. Our B is in front of the x term, so it's 5. And our C is 6. And what we want to do is we want to find two numbers that will multiply to give A times C and add to B. So first, let's list the factor P pairs of A times C. And A times C in this case is 1 times 6, so it's just 6. And then let's find any of those that add to 5. So one factor pair is 1 times 6. Okay, that doesn't work because if I go 1 plus 6, I get 7. So that doesn't work. So now I'm going to go up. I'm going to go 2. Well, 2 times 3 is 6. And check it out. 2 times 3. Oops, I did not circle the right one. What am I doing, Miss Gilbert? Let's just do that like that. Oh, I have it right in the answer. Gosh, sometimes I wonder. Okay, so 2 times 3 gives me 6, and 2 plus 3 is 5. Awesome. So what I'm going to do is I'm going to fill in a rectangle just like I did with the tiles. So in your top right, you're going to put your x squared term, which is x squared in our case. In the bottom right, you're going to put your constant term or your single tiles. We have 6 single tiles, right? And then remember when we had that 8x, we had 8x bars and we had to split it into 2? Well, that's what we're doing here. So these are the factors and we're going to put them in these boxes. It does not matter which one goes where, but just remember those are our x bars. So it has to have an x after them. I could have put 3x up here and 2x. And now what I'm going to do on the outside, just like we did before, really what we did is we found the greatest common factor for each row and each column. So the greatest common factor, actually I think I do, what do I do first? Oh, I do it here. So I'm going to take, remember this is x squared, so it's x times x. So we have x. This one, we have a 3x and a 6. The greatest common factor of 3 and 6 is 3. So we're going to put that out to the left here. Now we're going to do the columns. And I'm going to type that up here because I want you to know that. So I'm going to say find GCF of each row and each column. Just so we know that's what we're doing. Okay. Okay. Let me just get that back up. Okay. So greatest common factor of the first row is x. Greatest common factor of the bottom row is 3. Then greatest common factor of the first column is x. And greatest common factor of the second column is 2. And check it out. We have our binomials right here for us. So the answer in factored form is x plus 2 times x plus 3. And if you look at our tiles, that's exactly what we had before, right? We had x plus 2 times x plus 6. So it's just another way of doing this visualization with the tiles, but doing it with numbers and letters instead of the actual tiles. So we are going to do a different way of showing this. This is decomposition. Oh, let me get through this. This is called decomposition. It's doing the exact same thing, just not using this box format. Okay, and this is a way you will be taught by many teachers as well. So it's good to be familiar with both the area model and decomposition. I just forgot to mention here, if you want to check your answer, you can always expand it using the FOIL method. You can also check here, does x times x equal x squared? Yes. 2 times x is 2x, x times 3 is 3x, and 3 times 2 is 6. And if you add these together, what happens? We get 5x. So there's lots of ways to check it here, okay? So let's go on to decomposition. Again, this is the same steps, it's just not using the box. Okay, so we have x squared plus 5x plus 6. First, we're going to label what's our a, what's our b, and what's our c. Okay, then our next step, well, list factor pairs of a times c. A times c is 6 in this case, and adds to b, which is 5. So we're going to do the exact same thing. 1 times 6, that doesn't work. 2 times 3 does, though. So now, what you're going to do, this is exactly what we did. Remember how we split that 5x into 2x plus 3x? Well, we're going to do the same thing here. So we're going to split this 5x into 2x plus 3x. Then what we're going to do, this is exactly what we did, you're going to take out the greatest common factor of your first two terms and your greatest common factor from your second set of terms. So if we do that, if we have x squared plus 2x, we can only take an x out of both of them, and that leaves me with, well, x squared divided by x is x, and 2x, if I take the x out, I get 2. And then I'm going to do the same thing with this. Well, I've got 3x and 6. I can only take a 3 out of both of these, so I take a 3 out, and then what do I have left? Well, if I take the 3 out of this, I have x left, and if I take a 3, divide a 3 out of 6, I get 2. So I have this equation, and notice how they both have x plus 2 in them. That's a very good sign. That means you've done the right thing. So you're going to take this greatest common factor out of x plus 2 out in front. And what's left over? Well, x plus 3 is. And that's the exact same answer that we found using the area model. And you can check this by expanding using your FOIL technique. So there's two ways, three actually, because we looked at the algebra tiles for factoring any equation. So there you go. So let's do another one when a is 1. And I'm just going to use the area model because it is my preferred method, and seems to be the preferred method of most teachers. So it's very important to become familiar with it. So let's go through our steps here. Okay, so first we're going to label what's A, what's B, and what's C. So A in this case is 1, B is 7, and C is negative 18. So list the factor pairs of A times C. A times C is negative 18, and B is 7. So which of those factor pairs will add up to 7? Well, let's start with 1. So I always start with 1. So 1 times negative 18, or because it's a negative number, negative 1 times 18. Well, neither of those pairs add to 7. What's the next one? Well, I go up to 2. 2 times negative 9, or negative 2 and 9. Oh, hold on. That one adds to 7, doesn't it? If I do 9 minus 2, or negative 2 plus 9, I get 7. Awesome. So I have found my factor pair. So now we're going to put everything in the box. You're going to put your x squared term in your top right, your constant term in the bottom left, and then we're going to split we're going to split this x term, right, the 7x term, into negative 2x plus 9x, and you can put it in whatever box you want. So negative 2x there and 9x. And now you're going to find your greatest common factor of each row and each column. Okay, so the greatest common factor of the first row is x. Greatest common factor of the second row is negative 2. I take out a negative when they're both negative. Okay. How about greatest common factor of the first column? That's x again. And the greatest common factor, well, 9 and 18 are both divisible by 9. You might ask, why did I choose plus 9 here? Because I could take a negative 9 out of both of them, couldn't I? Well, one way to check that is these two numbers have to multiply to give the number here. So if I chose negative 2 here, this has to be plus 9 to get negative 18. Now that we have those greatest common factors found, we can put them in our binomial factored form. So x plus 9 is one of our binomials, and x minus 2 is the other one. And again, we can check by expanding. And you can see that here, just to check to make sure these multiply to give the things in the boxes. So x times x is x squared, x times 9 is 9x, negative 2 times x is negative 2x, and negative 2 times 9 is negative 18. Perfect. And check it out, 9 minus 2x gives us 7x, which is what we have here. So there we go. Let's see, do I have another one? I do. So this one's a little fancy. You might notice that this is a special trinomial from last lesson, but let's go through the steps of factoring this one. Maybe it slipped your mind and you forgot that it's a special trinomial. So let's go through the steps. Well, the normal equation is ax squared plus bx plus c. Well, let's figure out what a, b, and c are. A is 1. Oh, hold on, there's no x term. If there's no x term, that means b has to be 0, right? Because to make this term go away, b has to be 0. And then c is negative 25, because remember, c's always are constant. Okay, so we're going to list factor pairs of a times c. So 1 times negative 25 is negative 25, and they have to add up to 0. So I always like starting with 1. So 1 times negative 25 or negative 1 times 25, neither of those work. So then I start thinking, okay, what about 2? This isn't divisible by 2. Or is it divisible by 3 or 4? The next number that I can use is 5. And it's 5 times negative 5 would give negative 25. Ooh, so that's going to work. So let's fill up our square then. X squared in the top, negative 25 in the bottom right, and then 5x in one box and negative 5 in the other box. Is this starting to look familiar? So now we're going to take our greatest common factor out of each row and each column. So the top row, greatest common factor is x. Bottom row, negative 5. First column, x again. And second column has to be positive 5, right? Because if this is a negative number, and I already have a negative number here, this has to be positive. Now we have our two binomials, so now we can write it in factored form. Ooh, what does that look like? That is a difference of squares. You may have noticed that right off the bat from last lesson. If this is a perfect square and this is a perfect square, you can just bounce right to this step without having to do all these steps. But sometimes we forget, or sometimes it's not obvious, and you can still factor using this. And again, you can check by expanding. Okay, so what happens when A is not 1? We did some factoring there when A is 1. What about when it's not 1? Well, the very first thing you want to do is check to see if there's a greatest common factor you can take out of all three terms, because sometimes that can make factoring a lot easier. Now this time there isn't one, so now we're just going to go back to the steps we were doing before. Let's label our A, B, and C. So our A is 12 this time, our B is 5, and our C is negative 2. So we're going to list factor pairs of whatever A times C is. So this time A times C is 12 times negative 2, which is negative 24, and B is 5. So two numbers that multiply to give negative 24 and add to give 5. Let's see. 1 and 24, those don't add to 5. 2 and 12 pairs, those don't add to 5 either. 3 and negative 8 or negative 3 and 8. Oh, hey, wait, hold on. I need some water. Check it out, this last one. That one works, doesn't it? Because if I do negative 3 plus 8, I get 5. Perfect. So let's take our area model, fill it up. Your x squared term goes in the top right. Your constant term goes in the bottom left. And now these two boxes, you're going to use these two numbers with x's. Again, it doesn't matter which one goes where. Now you find your greatest common factor of each row and each column. So 4 can go into both the numbers, and then we're going to take out an x. So 4x. Here, the only number that can go into both of those is negative 1. Here we've got 12 and negative 3. Well, I'm going to take out a positive 3. Why? Because 12x is positive. So if this number is positive, this one also has to be positive, right? So there's a lot of checks and balances made into this system, which is great. Here of 8x and negative 2, well, I'm going to take a positive 2 because negative 1 times 2 gives me negative 2. If I put a negative here, I would get positive 2, and that wouldn't be right. So now we have our binomials, 3x plus 2 and 4x minus 1. And again, you can check by expanding. I'm going to do another couple examples with A is not 1, but first let's do this one again with decomposition. All the steps at the beginning are the same. So labeling our A, B's, and C's, listing factor pairs of A times C, and then figuring out which one adds to give B. Now in decomposition, come on, where is it? Where is it? There we go. I don't know why that took so long. You're going to decompose that middle term. So 5x becomes negative 3x plus 8x. And again, it doesn't matter what order you put these in. I tried to do it in a different order, so it was a little different. Now you're going to take out your greatest common factor of your first pair of terms and also the second pair of terms. So this first pair, I can take out a 4x, which leaves me with 3x plus 2. And the second pair, I can take it out a negative 1, which leaves me with 3x plus 2. Yay, those are both the same. That's good. So we're going to take this binomial greatest common factor out, which leaves me with 3x plus 2 times 4x minus 1, which is the same answer we got before, and you can check by expanding. It doesn't matter what order these binomials are in, because remember, it's the same as 2 times 8 is the same as 8 times 2. Okay, let's do another example here. I'm going to do another 2. So sorry that this video is a little long, but I really wanted to make sure you had that background again before we started. So our first step when we have a number that's not 1 in front of x squared, let's see if we can take out a greatest common factor. Well, here there's 3. We can take out a 3 out of all of these. So that means this equation changes into 3 times x squared plus x minus 30. And now we just have to factor this guy. So in this case, our a is 1, our b is 1, and our c is negative 30. Let's list the factor pairs of a times c, which is negative 30, and which one adds up to 1. So our factor pairs are 1 and negative 30, or the opposite, 2 and negative 15, or the opposite, 3 and negative 10, these still aren't working, 4 doesn't go in, but what about 5? 5, negative 6, or negative 5 and 6. Oh wait, this last one, finally, I didn't even plan that. Negative 5 plus 6 gives us 1. So now that we have that, we can set up our area model. But remember, we're only using this guy here, not the first equation, but the second one that we are factoring. We'll take care of this 3 at the end. So put in our x squared, we put in our negative 30, and then we break up our 1x into negative 5x and 6x. Take our greatest common factor of all our rows and all of our columns, and write those down as our binomials. But don't forget, we had this 3. So after you write down your binomials, don't forget to put that 3 back in front. Because if we didn't have this 3 here, we would not get this original back. So make sure you bring that 3 over and put it there. And finally, you can check your factoring here by expanding and then multiplying that answer by 3 to make sure you get that. Okay, I think I have one more. So this one looks a bit more complicated, doesn't it? So we've got 16x squared plus 26x minus 12. Well, first we check for our greatest common factor that can come out of all 3 terms. We can take a 2 out of all of them. That's the biggest number that can go into all of those numbers. So let's take that 2 out front. And now we're going to factor this guy. It still looks kind of complicated, but don't worry, we've got this because we know the steps. So A is 8, B is 13, and C is negative 6. So we're going to list the factor pairs of A times C. A times C is negative 48, and B is 13. So 2 numbers that multiply to give negative 48 and add to give 13. Okay, let's start. Start with 1. 1 times negative 48, or the opposite, that won't work. What about 2? 2 times negative 24, or the opposite, those don't work. What about 3? 3 and negative 16, or negative 3 and 16, that works, right? Because if I do negative 3 plus 16, I get 13. Perfect. Let's set it up. So 8x squared in the top left, negative 6 in the bottom right, and then our 2 numbers here paired with x's to fill in the boxes. Now we're going to find all of our greatest common factors of each row and each column. And then we have our binomials. Don't forget, we factored this trinomial, but don't forget we have the 2 in front. So don't forget to move the 2 down here. And that is the answer to that one. And that's basically as hard as it gets, okay? So this does take a lot of practice. I have made a summary of the steps to factor equations in this form. So you're always going to look for a greatest common factor. First, find your product of A times C, list the factor pairs of A times C, and choose the pair that adds to make B. And then you're going to use whichever way you like to factor, area, model, or decomposition, or algebra tiles if you have them, to factor them. Okay, so you try, you'd have a practice handout. Answers are provided on there. All of those, I think, have a not equal to 1, okay? I've also made up a knowledge hook mission if you would like some extra practice. And when you're done that, you can try the 5.2 quiz on Brightspace. So please let me know if you have any questions or if you'd like me to provide additional resources for this topic. There's some good ones on Khan Academy and stuff like that. So if you need extra help, please let me know. Just email me through the envelope in the top right hand corner of Brightspace. All right, see you next time.